Alrighty, let's see what we got. Count covered buildings, medium. Did this before? As always, never remember. You're given a positive and advanced city. You're given a 2D grid buildings where buildings at I is x, y denotes a unique building located at coordinates x, y. The building is covered if there's at least one building in all four directions, left, right, above, and below. Turn the number of covered buildings. Okay. So here this building is covered because there's something to the left, right, above, and below it. Only buildings 2 and 2 are covered. No buildings are covered. One building covered. Interesting. What I'm thinking of is just keeping track of for each row in each column, the lowest and highest in that, for each row, like row 2 here, y equals 2, the lowest building and the highest building in that row, and then for column, or x equals 2, the lowest and highest there, and for each building, if there's going to be, its value is between the low and high, or not equal, between, I guess the value is not the low high of the row, and not the low high of the column, then it should be covered. That would probably be an n squared operation. No, it's not n squared. It should be like 3 passes, I guess. 2 passes. So it'd be n operations. I guess that's fine. We'll try it out. So you need to keep track of the low and the high. Just the low and the high. Maybe wonder if I can just use a list and use min and max in the list. Okay, so I'll have row low is an array. Is the default dictionary? 10 to the 5th is not that many, so maybe I'll just use, instead of using a default dictionary, using a static array for keeping track of things. And I guess it should be infinity. Times 10 to the 5th plus 1, since I want to use just the value rather than offset it by 1. Row high. Column low. In theory, I can possibly keep this column high. And I'll say the rows have the same y coordinate. And the columns have the same x coordinate. For those points, actually I think maybe row low should start with infinity as its thing, and then row high should be like infinity. Okay, so for every x, y in buildings. So then I think, so looking at the x is going to determine the column that's in. So I'll say column low for this x is going to be the minimum of the column low for this x. And actually, I'll use those statements because those are generally a little faster because they don't have the automatic assignment. They only assign if necessary. Column low if this y is less than the column low for this x. So this x determines the column, and then the y determines how high it is. So if this y is smaller than column low of this x is equal to this y, if y is higher than column high for this x, column high for this x is equal to this y. If this x is less than row low for this y, row low for this y is equal to this x if this x is bigger than row high for this y, row high for this y is equal to this x. Alright, I think that's right. And then answer is equal to 0, and run through again for every x, y in buildings. If, let's see, the x, start with the x determines the column. So if the column low for this x is less than y is less than the column high for this x, and row low for this y is less than this x less than row high for this y, answer increments, it's covered. That means okay. See how it does in the grand scheme of test cases. Okay. It might need improvement. Memory is whatever. How to improve this? How to improve the internal question of life? How to improve? I do wonder if using min is actually faster than using a statement. So just for curiosity's sake, let's say I do column low of x is equal to min of y, column low of x, column high of x is equal to max y, column high x, row low of y is equal to min of x, row low of y, row high of y is equal to max of x, and row high of y. I assume it's going to be worse. Yeah. Worse in DD. Do, 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 do. I can maybe do this if else. Could do if else, maybe. Probably incorrect for that. I could do something where the row low and row high starts at the first building. That might be slightly faster. So the row low is, let's say, buildings at 0 at same y coordinate, so it should be x coordinate row row low. Yeah, should be the x coordinate. So something like buildings at 0 the x coordinate, buildings at 0 the y coordinate. No, just still also the x coordinate. Actually, what am I doing? This is not correct. This is not correct. It only works for the first row. I need to actually match it to the building itself, to the y coordinate of the building. Oh, yeah, that just doesn't work. I'll make this faster. If it's covered, I mean, you have to do a single pass in order to determine the ends of the rows and columns, no? You have to do a single pass. Are all the buildings in different grids? Yeah. Track of the lowest in a row, the highest in a row. I mean, I guess you could. I wonder if you just keep track of lists and then find the min max of the list. I don't know if that's faster than doing. Oh, that's faster than doing. Statements I assume is slower. Okay. Second attempt. I almost assuredly think this is slower, but we'll give it a whirl. Can't hurt. Row. Row. So for a particular row, row y's, rows have the same y coordinate. So I guess this row x's. So for every row, I'm going to check a list of the x coordinates for that row. Actually, yeah, so that'd be a list for everything. That seems like it'd be darn slow. Anyway, I guess I could do a default dictionary of lists. Default dictionary of lists. And then I'll need column wise. That's the default dictionary of list. And then I'll just rewrite this for every X file in buildings. I have to do append it to lists, and then for everything find the min and max, and then go over. Jeez. This is so slow. So many steps. But try. So the row is defined by the y coordinate. So the row wise. No, wait. I think I did it backwards. Row x is, yeah, so for this y coordinate that matches the row, append x, and column wise. So for this x that define where the column is, append this y. And then I need to go through and find the min and max. So I guess I'll use a tuple. I guess maybe now I just need another default dictionary of tuples. And column also has a default dictionary tuple where the tuple is the min and max of the row, min and max of the column. So for every row list in the row, if I do an iterator in row x's, this gives me the key. So I guess it'd be for every y in row x's, the y defines the placement of the row. I'll do x row this y append. Actually, I guess I should do tuple. Tuple is going to be the minimum of rows, row x's, this y, maximum row x's for this y, and row this y appends this tuple. No, it's just equals this tuple. For every x in column, tuple is going to be again min. I think I did this incorrectly. Okay, there we go. Minimum of this column. So column y's for this x, max of column y's for this x, and then columns for this x is equal to this tuple. Oh my god. Answer equals 0 for every x, y in buildings. If, I guess it'd be column x part 0, the first element of the tuple, is less than y is less than column x 1, row y 0 less than x less than row y 1. That's increments. Alright, let's see if this works. It works. Let's see how fast it is. I assume it's very slow. Oh yeah. Well, curiosity is sated, if not, even if it isn't getting me any closer to anything that's fast. Yeah, I mean, in theory, this was simple in my mind. In practice, it was definitely a lot of steps. Do 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 do. How to make this faster? Variable X, Y, and buildings. Is there a way to quickly determine? I mean, I guess you could sort it, but then sorting it by itself also makes it sorting it also makes it n log n rather than just n time complexity wise. No, I'm not even sure how sorting would help. Well, sorting kind of helps. Oh, oh, I mean, I wish you could just do like a count maybe. Like in theory, if you counted the number of things that have the same row, the same y coordinate, then the number of items in between, or the number of items minus 2 is the number of things that are the number of items that are possibly covered, and you ignore the end items. Interesting. So if you had it set that was things that are possibly covered, so if you kept track of this, I don't know. I guess you'd have an additional if statement here if you had something that was in a set of things that were covered. Indices where one of the coordinates are the low or high. It seems so convoluted, and also doesn't necessarily seem all that fast to have an additional set that you're checking. I guess this might be just one of those ones where I don't find anything faster than what I found, and what I found wasn't particularly fast. Alright, I'll look at one hint. Oh, they actually considered sorting. So how's that faster than this? How's it fast? How is sorting faster than find the min and max of the list of things? Group buildings with the same extra y values together. Hmm. Uh, uh, really? So instead of finding the min and max using this tuple deal, sort each row and column. So I guess I do for each y, I'm going to do sort row x's with y dot sort row x and column y's for this x dot sort, and then this would be this would therefore use if the row x is for this y, the first of that list is smaller than this x, is smaller than the row x is for this y, the last of that list, and column y's for this x is less than y is less than column y's at 0, less than column y's for this x at -1. Oh, did I return? Okay. Yeah, this seems as slow as anything else. Not slower. Yeah, what the hell, man? I wonder if this is a hint that doesn't necessarily go faster. Yeah, I mean, I guess it did go faster than my original implementation for kicking tuples, but not faster than not sorting it. It's really, you only sort when you don't need kind of singleton values from the list of sort values. If you know you're going to use the first and last values, then just keep putting in max, I think. Rather than having to sort everything and not caring about the in-betweens. Alright, anyways, the hints kind of didn't do what I was hoping. Just published. Yeah, I don't know. I just sorted list the buildings that are not the first list. Alright, whatever. I'm done. So I gave it my best and a couple of other shots, but couldn't find something that was very fast compared to the other sections. Main idea in solution is to keep track of the low and high for every row column, where row has buildings with same y coordinate. Column has buildings with same x coordinate. Then do a second pass over the array. If coordinates of building is in a row where its x coordinate is not low and high, low nor high, and similarly in a column where its y is not low nor high, then it must be covered. So that's just all this jazz. Yeah, time complexity is going to be O of n to do two passes. One to determine low high for every row column with a building in it, and second pass to do the count of covered buildings. Space complexity is going to be O of, I guess is O n. Is n the size of the thing? N by n. I think it might be O of n. And then to use a static or fixed sized array to keep track of the low and highs. Why isn't this just going to be as O of n? Yeah. I guess in theory it could be O of n squared. There's one spot for everything. What is this? I guess it might be O of n squared. No, there's only 10 to the 5th buildings. Yeah, it's not, even though the coordinates can extend to 10 to the 5th, it's not like it's not possible for every thing within the grid itself, within the 10 to the 5th by 10 to the 5th grid to be filled, because there's only 10 to the 5th buildings. All right.